Structural Analysis 2, Chapter 12, Portal Method in Frames. Let's jump to the portal method rules. There are some simple rules which we are reviewing in portal method. So it just says if we see a fix, whenever you see a fix both ends, either a column or a beam, either a horizontal member or vertical member, you just need to locate a hinge at the center of that member. So rules number 1 and 2, they just says the same things. It just says a hinge is place a hinge at the center of each girder, which means if you have both ends fixed, like center of each girder, since this is assumed to be a point of zero moment. As soon as you have a hinge, there is no moment there. And also at the center of each column as well. So it doesn't matter if you have a fixed end member. It doesn't matter if you have a beam or a column one. As soon as you check the both ends and you see it's fixed, you can locate your hinge there, and it just says it's a moment of zero at the hinge location. That's the first rule of portal method that simplifies to a far extent. It simplified our problem to a far extent, and also at a given the in fact we can say 1 and 2 are the same rule, but just apply to a horizontal and vertical member. And rule number 2, at a given floor level, the shear at the very bottom, the shear of interior column is twice of. So it just says, for example, if you are observing a structure with like two span over here, and you are applying a force of P at one corner, at the top corner of the structure, that V is distributed like this. It just goes by a V at this end, V at the outer supports, and like 2V at the center one. It is exactly like when you're simulating your structure like two separated frames, and each of them take the same even amount of shear. So when you combine it together, the interior columns, the interior one, the share of them is just twice of the outer one. So that's why this is twice of them. And likewise, if I just, what if I have like in such case, this is V, this is V in terms of if you have a horizontal force there. The interior column hinge is 2y. So this is 2v and this is 2v. In that sense, 6v is equal to P. That's how we distribute the horizontal force at the top to supports. That's, we just need to know. Just put a hinge at the center of each fixed member, and the second rule is shear is evenly distributed between the supports, but the share of the center one is twice of the sides. Let's apply them in a real world problem to see how we can solve a problem with the portal method, which is a very simple method. So if we have our frame, the very first rule is to place a hinge. So this is a gear, it's a fix. This is also a fix. So we can apply a hinge over here, one over here, and all to the end. And that simply says, and if we just call the middle one like M, I, J, and K, O, That's just an L, just the naming of them. So we just locate a internal hinge at the center of each fixed member, either horizontal or vertical, as you can see in the figure easily. As soon as we have that, we can dissect our section. For example, we had a cut off the point of these cuts, the hinge, it just says you can freely cut your structure and there is no moment. They're just horizontal and vertical component. It makes problem far simpler to solve because we already eliminate the moments. So as you cut your structure through by this line, it just simply says we already know the share of horizontal force, which is V at the sides, and then the 2V at the center, 2Rs of the sides, and they are responsible for the total of 1200 pounds, which we have here. So summation of forces in X goes 0, positive X is this way, and 1200 minus 6V just gives a V is 200 pounds. So if you just replace there, it's 200, this is 400, 400, and again, summation of them should be cancel all these 1200 over there. As soon as we have that, the only task we do need is to calculate Iy, Ky, Jy, and Ly, the vertical component of all force. And as soon as we have that, we are done with our problem. So if we just move to this part and we just call this one like if it's at the center, the total was something like 16 feet in vertical horizontal direction and like 12 of main structure feet in vertical. So if you cut it through, it just gives you a 6 feet in height and 8 feet in length. So, and in M, definitely we don't have any moment because it's an internal hinge. So we have like M, Y component of point M, and also X component of that. So a simple static summation of moment about M goes 0, it just gives us a negative 200 times 6 due to our counterclockwise positive direction, and it just simply gives us a y component. I is 150 pounds and also downward. And likewise, you can jump to the neighbor member and don't forget to translate the forces you have over previous part for new member. So just remember, if you have a hinge at the other side, want to translate it here. So if this is 150, let's have it this way. If this is the other side, this is for the other part of our joint on the other member. And as soon as you want to translate it, just flip-flop the directions. So it just goes like this. So this is the part from previous member. Just flip-flop the direction for arrows, then you can simply get the direction of your forces. So that's a simple balance between them. So we have a 1000 push, 150 down at this point, at point M for our new member, and we do know the horizontal component of J is 400. So 1000 minus 400 is simply gives us nx is equal to 600, and like by simply getting a moment component about point N outer part, it just gives us y component or jy is equal to 0. And let's move to the other part. Again, we have to translate our forces from the previous member, flip-flop the arrows and transfer it to the new member. And it just gives us, if this is 600, this is 400, all x is simply 200 pounds. And like by symmetry, you can easily see ky is equal to 0. If not, you can mass calculation, moment calculation. And if this is 0, 150 downward should cancel out by 150 upward. So we got the force over here as well. The next member, we just transfer the forces, flip-flop the direction of arrows, and then can easily get all the forces and just move to the bottom part, because if you remember, we have all the horizontal member. Now let's cut the vertical member by halfway through. So if the total vertical is 12 feet, if you cut it by the location of hinge, it just says you have 6. We know already AX is 200, and the same force should be cancelled out by another in the opposite direction, and these two creates a couple of 6 times 200 is gives us a moment of 1200. Likewise 400, double of that moment, and h is also 1200. So we can easily see the moment at the sides is a half of moment at the center as well. As soon as you have all the forces, and also we just transfer ay or hy from previous part, because we already calculate the horizontal and vertical components of our force. Then we have all the reactions. We can just report problem. We solve more problem. Thank you.